In our big picture of statistics, we've taken a look at, started to take a look at probability. We looked at probability theory in the last video, and in this one we're going to take a look at random variables and what they are. So I'm going to switch over now, and here we are. So I've opened up the random variables into all its subsections. So we can see that there are only two types of random variables. There's discrete and there's continuous. What do I mean by these? Well, actually, when I talk about statistics, I tend not to use statistical jargon. I don't use statistical terminology. So when I hear discrete, I think categorical. So it's categorical data. And categorical data is not measured, it's observed. It takes distinct values, such as male or female, and these values are finite. And what this means is that in between categories, there is nothing. There is nothing in gender. You've got male and you've got female. You don't have subcategories and sections, degrees of maleness or degrees of femaleness. You categorize it as male or female. A size variable could be small, medium, or large, for example. So discrete data is categorical. It's observed data, which takes distinct values and is finite. On the other hand, you can have continuous data. Continuous data is measured data, and you measure it with a stopwatch or a ruler or a jug, some kind of measuring implement. And the data here is infinite. And what we mean by infinite is between any two data points, there is an infinite number of subdivisions. So the difference between 1 meter and 2 meters, you can chop that up into centimeters, you can chop it up into millimeters, micrometers, nanometers. You can chop it up into as an infinite number of subdivisions, and you can actually measure that subdivision. So this is it, really. Random variables. There are two types of random variables that's going to go into your study. You're going to have data that is continuous, that is measured, and you're going to have data that is discrete or categorical, and these are observations. Remember before we talked about our probability box, right? So for every variable that you've got, it's going to be either discrete or it's continuous, and it's going to go into your probability box. Just a quick word on different types of data. There are some types of data that you will think don't fit with discrete or continuous. Let's say, for example, you're collecting people's dates of birth. You're collecting these so that you can calculate their age. So date of birth, does that fit? Is that discrete or is it continuous? Actually, it doesn't matter, because you're not going to do any calculations on date of birth. Date of birth itself is not important. What is important is the difference between the date of birth and the date of death, or the date of diagnosis, or the date of surgery, whatever it is that you're trying to measure. It's the difference between two dates, and then you've got a time period. And what type of data is that? What type of random variable is that? Well, it's continuous, because there are subdivisions between each point. In each day, you can cut it down into hours, you can cut it down into minutes, into seconds, into milliseconds, and so on. You can chop it up into smaller and smaller bits. So, two types of random variables. There's discrete random variables and continuous random variables, and these go into your box so that you can do your experiment. Okay, that's enough for this video, and we're going to go on to probability distributions for the next one.